Assalamu alaikum wa rahmatullahi wa barakatuh, and welcome to another matric revision session on Facebook and YouTube. We are using these platforms to allow matrics to get information that is critical to the upcoming papers. Today we'll be focusing on mathematics paper 2. This will be the first session, and we'll be focusing on trigonometry, quite an intricate subject, and so I'm sure that you'll find tremendous benefit in this session. As always, our guide on this journey is Sandra Dixon. She's a BSc in mathematics, grade 8 all the way up to grade 12. And without further delay, I'd like to greet our guest. Sandra, good day and welcome to you. And thank you for joining us once again.
Good morning.
Good morning. Well, I think without further delay, I will hand over to you to proceed with today's lesson.
Okay, thank you very much. Okay, today I'm going to do grade 12 trigonometry. Now, my experience in the past has shown me that trigonometry is probably the section of paper 2 where you guys get the least marks. I've thought a lot about it, and I think the reason may be that trigonometry is such a vast field. So therefore, the questions that can be asked is like really numerous. So that is why it's difficult to prepare for trigonometry. But let's go through paper 2 of the November exam of 2020. And please make note that the papers more or less all look similar, definitely not the same, but the concepts that I'm going to be dealing with today, you will find in every single paper. So therefore, it's very important here, if you listen to me, to concentrate on the underlying facts or the underlying theory to answering these questions, rather than just looking at how we arrived at the answers. So let's jump right in. It is question 6 in paper 2 of 2020. And normally trigonometry starts off with a section that says, answer the following without using a calculator. Now, first of all, you need to realize, apart from like really punishing you for not allowing you to use a calculator, this actually means something more. So the section in trigonometry where you are not allowed to use your calculator normally hinges around two areas of trigonometry. The one area are your special triangles, and those you need to learn off by heart. And those are when you find either 30 degrees, 45 degrees, or 60 degrees anywhere in a question. So it could pop up anywhere. So you need to know your two special triangles if we see 30 degrees, 45 or 60 degrees. Now, in this case, we do not see that. So your second option would be is to do the question with the aid of a sketch like we have open on our slide at the moment. So this sketch can be presented to you in many, many, many formats. But lately, they actually give you a half-drawn sketch and you need to complete it. So in this instance, they gave us, in the diagram, the point P is -5 semicolon 12, which means, and that is what you guys often miss, the -5 is your X value. Let me point at it. So it's your X value. So basically this -5 goes on the X axis of the sketch, where I'm circling here at the bottom, and I typed it real big so that hopefully you guys will see it. So now if we look at the 12, where does the 12, what does this 12 on the sketch means? This is your Y value. And that is why it's your Y, not axis, but your y value. So right now we have a sketch, and what we need to do is to take the half-drawn sketch and always complete the triangle back to the x-axis. Very important. Always back to the x-axis. You will not complete it like at the top. I don't even want to mention it, all right? Always, doesn't matter where this triangle is, you would complete it, this red dotted line, back to the x-axis. And that will form a 90 degree there at the bottom. So we have got a right-angled triangle. So now they're telling us, now we need to know where the angle is that we're working for, and that's theta. Now that always starts at 0, because remember here where I'm pointing at now is 0. And normally if we go along this Cartesian plane, it would go anti-clockwise. First quadrant, second quadrant, that is where our triangle is at the moment. Third quadrant, fourth quadrant. That is how it works. So angle POT, which is theta, and when we draw it, and that is not in our sketch, it starts at the 0 and it ends against the hypotenuse, right? So it starts at 0 and it ends at the hypotenuse. And that makes it a little bit confusing to you guys, because now this angle is sitting on the outside of our triangle. So we are using the acute angle that I'm pointing at the moment, the acute angle. Why? Because the first basic rules in any trigonometry is, first of all, you get rid of negative angles. And if you find obtuse angles, like this theta, we work with the acute angle. Right, so that is why when we use this, we pretend that we're sitting here where I'm pointing at the moment. So right, in the diagram, P is negative 512, and T lies on the positive x-axis, and angle POT is theta. Now they want the value of tan theta. So here they made it real easy. Tan means toa, opposite. So your opposite is this one over here, divided by your adjacent side. So tan theta would be 12 divided by negative 5. And please note, when you do this, imagine you used your calculator and you typed in tan theta. So your answer does not have a tan anymore. The answer is just plainly 12 divided by negative 5. And we would leave it like that because trigonometry is based on ratios. So to give a ratio as an answer is good enough. So that takes care of question 6.1.1. So here we did not use a calculator, and we used our trigonometry ratio to get the answer from a sketch that we had to complete. So that was only 1 mark because we actually did not have to do much work to get to this. Now let's look at the next question. Now on the next question, it's a little bit of a busy slide. So what I've done is I kept the main question at the top, and our new question 6.1.2 is now calculate the value of cos theta. So now this time we're not that lucky, because if we go to our sketch and we do cos of theta, remember we are looking from here where I'm pointing at now, and cos is adjacent divided by the hypotenuse. So that is car. So in English, the little help that you need to learn is that it is so car TOA, where SO is for sin, opposite over hypotenuse. In this case, we want cos, which is CAH, C-A-H. So it's your adjacent over your hypotenuse. So by now you can clearly see what they've given us, we do not know the hypotenuse. But we know that the angle here, this is a right-hand triangle. So we're going to use Pythagoras to calculate the hypotenuse. So OP here on the right-hand side will be the square root of 12 squared plus -5 squared. So those of you that may struggle with Pythagoras and don't know whether you must put a plus there or a negative, just mark these two. Mark your adjacent and your opposite sides. If you have them, it's a plus. If you have to calculate either of them, then it's a negative, and you always put the longest side first, and the longest side is always the hypotenuse. Right, so in this case, we do have the opposite and we do have the adjacent. So we did 12 squared plus -5 squared. And please note the brackets, because if you do not put a bracket here by the -5, if you omit the brackets here and you work your calculator, the calculator is going to get -25 as an answer. Please check it in your calculator. The way it's typed out here, the answer is +25. So the omission of those two little brackets can really give you a wrong answer. Please note that. So the hypotenuse is 13. So now at the bottom, I've put the answer. If we want cos theta, cos is CAH, so it would be your adjacent divided by your hypotenuse, and that will give you -5 over 13. Now this is 3 marks because they give you a mark for the Pythagoras and calculating the 13 and then getting the correct ratio. So these were easy marks, so make sure that you really understand how Pythagoras work so that you do not do this incorrectly. Right, the next question, now it gets a little bit more involved. 6.1.3. Now we have a new point, SAB. Now we need to find out where is this point. So it says the point is in the 3rd quadrant. Now remember I said to you earlier that quadrant 1 is where I'm pointing now. We go anti-clockwise. So quadrant 2 is where our triangle is, and the next quadrant is your quadrant 3, the 3rd quadrant. And now important, they tell us that TOS is theta plus 90. So what they mean by this is that we have theta here on the original drawing, and we add 90 to it. So if we add 90 to it, S can only be where I've drawn it at the moment. Okay, so that was a little bit difficult to find out where S is supposed to be. But I followed the question just like a recipe. And my recipe said, my first clue was 3rd quadrant. My second clue was, it is theta plus 90. Right, so you just follow the recipe. And they also tell us that OS, so the hypotenuse here, is 6,5 units. Now they want the value of B. In other words, the Y value of point S. So let's see, what do we have? We have a hypotenuse of 6,5 units. And Y is the opposite side of this new triangle. So now we can write down, we start off with sin TOS. And sin TOS is sin theta plus 90. So we basically write down what we saw on the picture. So sin TOS equals sin theta plus 90. Now if we work with co-angles, remember, whenever there's a 90 in the picture, we can use the co-angle and swap it to cos. So if I could just explain this, the sin theta plus 90 is in your second quadrant, and sin is positive in the second quadrant. If we swap it to cos, it just becomes cos theta. This is a very important fact that you need to know. So if you don't understand how that was done, please make sure that you go and look at the theory. So now we use the sin theta plus 90, because sin theta plus 90 is the angle over here. Because remember, we start at 0 and we end next to the hypotenuse. But we use the angle, the acute angle. So sin of theta plus 90 would be our B value that we're looking for over the hypotenuse. So that is how we got B over 6,5 units equal cos theta is in our original triangle. Our original triangle, because theta is over here. So we would then go adjacent over hypotenuse, and that would be our negative 5 over 13, which we got from our previous question. So we got that from the previous question as well. So now it's plain algebra after this. If there's an equal sign, we can do cross multiplication. It's a very specific operation. You can only do it if you have a fraction on the left and a fraction on the right with an equal in the middle. So B times 13 would equal negative 5 times 6,5. So basically, we flatten, by doing a cross multiplication, we flatten two fractions. It's similar to doing a LCD, right? You will get exactly the same answer. So now B would be negative 5 times 6,5 divided by 13, because we have a multiply on the left-hand side, and if we take it across the equal, it becomes a divide, the opposite. And in your calculator, you would get that B is negative 2,5. Why we keep the negative? Because B is a coordinate, so the sign has to go with it. If they only asked for a length, we would answer 2,5. But in this case, they want the y coordinate, and that is negative 2,5. So yes, this is complicated, but not impossible to do, and you will get questions of this nature in the paper that you're writing on the 8th of November. Let's go to the next question. Now with these ones, you should get all your marks. So let's unpack this question. So it says 6.2, determine without using a calculator the value of the following trigonomic expression. So we have sin 2x cos negative x. Please note the plus there. That plus tells you it's two separate terms. Very important. It's not joined. It's two separate terms. And then it carries on saying cos 2x times the dot means a times, sin, open bracket, 360 minus x, close bracket, all divided by sin 180 plus x. So now we know we are going to use our reduction formula to do that. But we also see that there's a sin 2x, there's a double angle, and there's a cos 2x, a double angle. Just take note of that. So grab your information sheet. I'm grabbing mine because we are going to use it shortly. Sorry, mine was just a bit further away than what I thought. So let's have a look. That's sin 2x cos negative x plus cos 2x. I call it, it looks like a little bit of a mess. However, you should recognize the sin cos sin. So that should give you a hint that we are going to use compound angles. Maybe, all right? We just file that in the back of our mind. So before we go to the blue bits here, let's see what can we do just to make this thing a little bit more manageable. And I said earlier that you guys, negative angles like this cos negative x, we must make negative angles positive angles, and your acute angles you reduce. So we'll end up getting, so we're first going to work with the cos negative x, and we're going to work with the sin 360 minus x and the sin 180 plus x. So we rewrite the sin 2x times. Now cos negative x means if it's negative, you go around your Cartesian plane in a clockwise manner. And it will take you into the fourth quadrant. So, and cos is positive in the fourth quadrant with your all stations to Cape Town. I have a slide a little bit further on where I explain that. In fact, yeah. So it becomes cos x. Plus, we leave the cos 2x alone in the second bit. And sin 360 minus x. That is also in your fourth quadrant. And sin is negative in the fourth quadrant. So this reduces to negative sin x. At the bottom, we have sin 180 plus x. That takes us to the third quadrant. And sin is negative in the third quadrant. So that is how we get negative sin x. Right, so now we have sin 2x cos x. But you see now I made all sorts of arrows here. That negative sin, we never leave negatives in the body of any part of an equation. We normally bring it to the front. So if that negative comes to the front, it changes the plus into a negative. Very, very important. Because we would be tempted, and when I did it the first time, I thought I was going to use the compound angles with a plus, but it turns out to be the negative, right? So careful, little catches. So it becomes sin 2x cos x minus cos 2x sin x, because the negative is now in the front over there, over negative sin x. So now if we look at the blue that I've got up here, can you see this is sin cos sin? Sin cos sin at the top. And there's a negative, so we choose the negative. So this we get from our information sheet. And we see that our angles, alpha is 2x and beta is x. So now we transform it back to the left-hand side. So it will become sin x 2x minus x over negative sin x. And then we can do a calculation here because this is 2 apples minus 1 apple. It's 1 apple. So it is sin x over negative sin x. The two sins cancel. So our answer is negative 1. Right? So pretty difficult. But what you guys miss is this basically makes our head spin, all of this. So remember, if you see something complicated like this, remember your information sheet and remember your compound angles and see if it does not have something to do with your compound angles and whether you cannot reduce it to something real simple, which is your basic compound angle equation on the left-hand side. Right. So I can understand that you guys find this hard because it is hard. Right. So now the next one, question 6.3. Now the general solution. So up front, I'm telling you, this will be in every single paper, and you may even have to apply it more than once. So work with me through this, and this is another section that you cannot go and write your second paper on the 8th of November if you cannot do this in your sleep. I'm that adamant about it. So this general solution, it's got a couple of flavors, but basically the general solution is quite a lot of algebra. So let's see what's going on here. The question says 6 sin squared x plus 7 cos x minus 3 equals 0. Now from my algebra classes, I've told you guys that if there's a square anywhere in an equation, we want a 0 either on the right-hand side or on the left side. So if you had a square here, and for argument's sake, they had the 3 on this side, you must know immediately it's got to be a 0. So you would transfer everything that's here to the left-hand side because it makes up a trinomial. So now, a trinomial is typically like x squared plus, say, 2x plus 1. So it would be something squared, and then the same thing. That has to be a sin or that has to be a cos. But it will be the same thing and then some number. 3 terms in a trinomial. Now in this case, we don't have any identity for just a plain cos. So we'll have to do something to the sin, which I've got in yellow here. So now we use the identity that says sin squared x plus cos squared x gives us 1. Now that identity, let me see, is that on the formula sheet? I do not think so. So that is one that you need to know. So basically, if you then want to make sin squared x the object of that equation, it would turn into 1 minus cos squared x. So we go from this yellow sin to this step by using the identity sin squared x plus cos squared x equals 1. Right. So we replace the sin squared x with a 1 minus cos squared x plus 7 cos x negative 3 equals 0. Now we do some algebra. we multiply the bracket out, because remember, whenever you've inserted a bracket in algebra, you will get rid of it in the next step. So 6 times 1 is 6, minus 6 times cos squared x gives us 6 cos squared x, plus 7 cos x minus 3 equals 0. Now we simplify it further. It's a trinomial, so we want the squared, the term with the square first. So negative cos squared x plus 7 cos x, because remember, it's got a square and it's got to be followed by the same type of thing over there. And then we do 6 minus 3 gives you plus 3 equals 0. Now we need to factorize this, because remember, well, you should have picked up when I started saying that we're working with a trinomial, you should know that you're going to factorize it. But factorizing anything with a negative in front, it's possible, but it's difficult. And the beauty of an equation is that we can change the signs throughout. So we multiply by a negative 1, or we just plain change the signs. So that negative becomes a positive, 6 cos x squared. The positive becomes a negative, 7 cos x, and that positive becomes a negative. Right, now we have a workable trinomial. The 2 says that we need 2 answers. So the brackets will factorize into 3 cos x plus 1, 2 cos x minus 3. Now, if you follow my algebra classes, I do have a video where I show and explain properly how we get from the trinomial to it being factorized. But if you do not know that method, there's a formula on your formula sheet, the very first formula, which says x equals negative b plus minus the square root of b squared minus 4ac over 2a. That should ring a clear bell. Now you can use that formula to factorize this. If you use that formula and the calculator, you will immediately get your answer that cos x equals negative third, and cos x equals 3 over 2. Or if you did it by hand, you would have to set this to 0, the first bracket to 0, and the second one to 0, and solve for cos x. Now, you need to know that sin and cos is only valid between negative 1 and 1. Because if you draw the mother graph of a cos function, you will see that it oscillates between negative 1 and 1. So if we turn the 3 over 2 into a decimal, it is 1,5. So it's bigger than 1. That is why it is no solution. Okay? That is why it's no solution. Because cos can only have an answer, maximum negative 1, minimum negative 1, maximum 1. So that leaves us with the left-hand side here. So we're going to do the general solution only with this side. So I've done the all stations to Cape Town here in the white block, because you need to know clearly. Let me just move. Okay, it doesn't want to move. Oh, golly, now I made a mess. There we go. Oh, now I made a mess. Let me just fix it up. Now it's somewhere right. Don't know how this works. So there is some luck in some things in life. Okay, so let's go back to this. Now my little negative sign is circled properly. So when we do the general solution, we use that negative to find the quadrants where we are going to do our solutions. So we're working with cos, and on the right-hand side, cos is negative in the second quadrant and in your third quadrant. That is why our solutions will be in quadrant 2 and quadrant 3. So this is very important that you understand what the purpose of that negative sign is. It only tells you which quadrants you are going to use. So now to get your reference angle, we will do the inverse of cos x. So you will go to your calculator and you will do shift and you will do the cos with a little negative number. It's on the yellow writing on the calculator. So you would do cos -1 of a third, just the third, and it will return a reference angle of 70,5287 ... Now we haven't finished. This is not the final answer. That's why you don't round at this stage. So take note of that. 4 decimals is enough. Now in quadrant 2 over here, this is the 180 minus, because 180 is over here where I'm pointing. And to get there, it is a 180 minus your angle. So we will do 180 minus your 70.5287 plus 360k, comma, k is an element of z. Now, for those of you that do not understand this, 360 means 1 revolution. So if we make k 0, the 360 will fall away because k is an element of z and z is a whole number. So this represents the waves of your cos function. So 360, if you use 1 for k, it would be 1 revolution. If you make k a 2, it would be 2 revolutions. In other words, twice around. So the idea of the k is an element of z tells you that k can only be whole numbers. Now we use our calculator and we say 180 minus the 70, and we'll end up, and its estimate, because we rounded, the rounded number is 109,47 plus 360k, k is the element of z. In the third quadrant, now we over here on the white block, and that is your 180 plus. So we would do 180 plus the 70,5287 plus again 360k, k is the element of z, and we use our calculator and our answer is rounded 250,53 plus 360k, k is the element of z. How do we know 2 decimal places? In the front of your paper, it will say round everything to 2 decimal places unless stated differently. That's why we have to know rounding. Now, this is the general solution in its vanilla flavored format. I will, in later lessons, do the other versions of it as well. And that is where they give you an interval, and then we actually need to do more steps. But for this one, this is your final answer. Now the next one is a level 4 question, and it's meant to be difficult. So let's see how will we approach this. They tell us, they give us x plus 1 over x equals 3 cos A, and they give us x squared plus 1 over x squared equals 2. Now, whenever you see a question like this, where they give you two things, you need to look at where it's related or what is similar in both of them. And what is similar here is the x plus 1 over x. Here's also a x plus 1 over x, except it's now squared. So we're going to start on this side. So we write down x plus 1 over x equals 3 cos A. We're starting on the left-hand side. We want to turn this x and that x into a x squared. Right, so put a bracket around it and square it. Let's see what happens. But it's an equation, so if you do it on one side, you need to do the same on the other side. That's why we're squaring this side as well. So this is a trick that you need to remember, because it's nothing other than a trick. So, because what are they doing here? They are checking whether you can multiply out a bracket with a fraction. So the way we do it, and I'm going to do it with a rule. You can do it separately by writing x plus 1 over x and another x plus 1 over x and multiply it out the long way. I'm going to use the rule. So it's x squared plus 2 times the two terms multiplied together. So the rule says multiply the two terms together and multiply it by 2. That's the rule for any squared thing like this. And I've written it out. 2 times x times 1 over x plus, and we square this. 1 times 1 is 1, and x times x is x squared. Now, here's a little catch on this side. Remember that 2 makes that 3. That's a 3 squared. That's where the 9 comes from. So it's 9 cos squared A. See, this is plain algebra. So now we simplify this lot. So x squared plus, there's a 2 times, that x cancels with that x. So we end up with having 2 times 1, which is 2. So we will have x squared plus 2 plus 1 over x squared equals 9 cos squared A. Now it's time to look, because we see we have an x squared and we have a 1 over x squared. Now it's time to look at the right-hand side. Because that is what they mean, is that you need to use the right-hand side to get to your answer. So now in this case, for simplifying sake, I've written the x squared and the 1 over x squared together, plus 2. So I just rearranged it, equals 9 cos squared A. Now these two, they are telling us if you add it up, you get 2 for an answer. So we can replace this in the little bracket with a 2. And there's the other 2, equals 9 cos squared A. If we add the two 2's up, it's 4 equals 9 cos squared A. And if we want the cos squared alone, it is 4 divided by 9 equals cos squared A. Right. All of this we needed to do because we wanted the value of cos 2A, which we still don't have. And if you note, this is 5 marks, so they expect us to work. They don't give us marks for this. So far, we would have gotten a mark for the squared over here, maybe multiplying it out and ending up here. So let's look at the next slide. Oh, sorry, I'm carrying on in it's not the next slide, it's on the right-hand side. So now the question says we must find cos 2a. Now, I could have said it in the beginning, but I'm saying it now. When you read any of these questions and you see that there's a single angle and a double angle in the same question, you will have to, at some stage, have to convert from the one to the other. Because what we've done up to now, we still have a single angle. But the question says, I must have a double angle. So back to the formula sheet. So we look, cos 2a has got 3 possibilities. But we need to get cos for an answer, so we're going to pick the third option. It's almost at the bottom of the information sheet. So from the information sheet, we will write down cos 2a equals 2 cos squared a minus 1. Because what do we want to do? We want to convert from this a over here to a 2a over there. And the only way you can do it is via the equations on your information sheet. Because can you see over here, we've got a 2a on the left-hand side and an a on the right-hand side. So to do the conversion, we want 2a as an answer. So we have 2, but we've just worked out cos squared a here on the left-hand side. So we replace the cos squared a with 4 over 9 minus 1. And now it's simple further. So it becomes 8 over 9 minus 1, and that gives us negative 1 over 9. Please use your calculator to do it. Okay, they do say without a calculator. So you would have to get the LCD, but at this stage, 8 over 9 is 1 less than 1. So 1 is bigger than 8 over 9, so that's why we get a negative 1 over 9. But check it with your calculator that you actually did it right. So yeah, this was a difficult question, 5 marks, designed to rob you of marks. Right, now comes, if the first slot wasn't difficult enough, now comes your 3-dimensional question where you'll have to make use of the sine or the cos rules. So there's a whole story. A landscape artist plans to plant flowers within 2 concentric circles. So our flowers are in between these 2 circles. A vertical light pole, that means if it's vertical to the ground, there's got to be 90-degree angles. So anything that's vertical makes a 90-degree angle to the ground. Okay, we read all of that. RS is a pipe, which I guess they're going to water the flowers with. So what have they given us? The radius of the inner circle is R, and the radius of the outer circle is QS, the red over there. The angle of elevation from S to P is 30 degrees, and angle RQS is 2x, and PQ is root 3R. Note the R is not part of the root. It's outside the root. So basically, if you look at these pictures, we actually have 4 triangles. It's the one here at the back, PQS. There's another triangle, PQR. Another one, RQS. And then there's another 4th triangle, PRS. Right, so there's a whole bunch of angles, and the art of these ones is to pick the right angles to work with. Okay, so let's look at the first question. Show that QS here at the bottom is equal to 3r. So how are we going to do this? So we look at our triangles and we see that QS is part of triangle PQS. Because we always try to work with a right angle triangle first. So let's, in triangle PQS, we use this angle here. We write down the 30. And they've given us the opposite side. And we want to work out the adjacent. So it's a TOA. That's why we put a tan in front of the 30. And then we execute it. So tan of 30 is root 3r over QS. Cross multiplication. So QS times tan 30, cross multiplication like that, equals root 3r times 1 over there, the one that's not written there. So if we want QS, it becomes root 3r divided by tan 30. And if we put that in the calculator, can you remember tan 30? We could do a special triangle, but they don't tell us here not to use our calculator. So we would put in our calculator root 3 over tan 30. The answer is 3. And don't forget the r. You can't put it in your calculator, but the r stays. So in other words, QS equals 3r. So now what I've done with my next picture, I've put the 3r in. So as you go along with doing these questions in any geometry, when you calculated something, put it onto your picture. Right, so now I want in terms of r. Now what it means if they say in terms of r, that means your answer must have a r in it. Okay, that's all that it means. In terms of r, in terms of x, your answer need to contain that letter. So we want the area of the flower garden. So that is where I'm pointing at now. The area between the two concentric circles. So area of the garden, so it would be the area of the big circle minus the area of the small circle. Then you will be left with a flower garden. So basically we're taking the middle bit away. And the formula for the area of a circle is pi r squared. So the first time it's pi r squared with QS, which is the radius of the big circle, minus pi r squared. R is the radius of the small circle. So pi times 9r squared, remember that 2 goes with the 3, so that's how we get the 9, minus pi r squared. This is ugly. We always write the number in front. So this is 9 pi r squared minus this. Where do my 3 come from? That must be a r. Pi r squared. So we see we've got 9 apples minus 1 apple. This is the same. So it gives you 8 pi r squared. Because you can't do this in a calculator because we don't know r. So our answer is 8 pi r squared. So that was pretty easy. Now they want us to show that RS, which is red at the bottom, is equal to r square root 10 minus 6 cos 2x. And this is where most of you actually skip the question. But don't. Remember, this question is about the sine rule and the cos rule. Now we normally know a dead giveaway for the cos rule is a square root, because the cos rule is the only one that ends up with a square root. Because if we look at the cos rule over here in the blue, can you see there's squares everywhere? So if we want a to get rid of the square here, we need to do the square root on the right-hand side. And the other dead giveaway, we want to calculate RS, the red at the bottom. So it is quite obvious that we are going to use triangle QRS. And we also see we have a side angle side. Another dead giveaway that we're going to use the cos rule. So let's apply it. So remember cos rule, we always look for side angle side. So RS equals the square root of R squared plus the other side, 3R in bracket squared, minus 2. Take those two sides and multiply them, R times 3R, cos, and the angle here is 2x. Okay, so we are applying the cos rule straight away. So now we simplify this. So we'll end up having R squared equals 9R squared minus 2 times 3 is 6. R times R is R squared times cos 2x. Now this is where they catch you guys out, because these all look like apples. So you guys normally do R squared plus 9R squared minus 6R squared. You can't do that, okay? There's a cos adjoined to this. So you cannot. This 6R squared belongs to the cos. But we can add up the R squared plus the 9R squared, which gives us 10R squared minus 6R squared times cos 2x. So now they're checking whether you can factorize. So we see R squared as a common factor. We take the common factor out, and we end up with, we divide that into the first term, we end up with 10 minus, we divide the R squared into this second term, and we end up with 6 cos 2x. Now, all the time you're doing this, have a look in your paper, what are we working towards? And we can see that we're getting close. The only thing that's now not looking too good is the R squared in there. But we can get the square root of R squared, and that is R. We cannot get the square root of this lot, so it stays under the root. And there we've proven that RS equals to what they asked. And then your last question on this lot. If you couldn't do 7.3, remember it's normally followed by a simple question where they actually give values. So they tell us now, R is 10 and that's 2 marks. So don't skip it and don't miss it. R is 10 meters and X is 56 degrees. So you would just plain go, sub it into the formula, work it out in your calculator, and that answer is RS is 35 meters. Okay, I think I've covered this stuff to the best of my ability. You do have my sympathy. It is difficult, so you need a lot of practice, because you cannot get an extremely low mark for this section, because it will affect your whole paper. So you need to be able to do the basics to at least get the maximum number of marks for trigonometry that you can get. Thank you for listening, and bye-bye.
Well, Sandra, I want to say a big thank you to you for joining us once again. And yeah, I think hopefully people have benefited tremendously from this, and we hope people will do well in the trigonometry papers. And yeah, if people want to get a hold of you, it's Sandra Dixon 67 at gmail.com if they want have any questions around the lessons. And also, if they would like any private tuition, they may contact you, Sandra Dixon 67 at gmail.com. Sandra, once again, a big thank you. All the best. Stay safe, ma'am, and look forward to next week.
Okay. And next week we will be doing some more Euclidean geometry. And if there's enough time, I will go through the stats as well, the median, mode, scatter plot, ogive, and that stuff. I will go through that as well.
Fantastic. We
Bye-bye.
appreciate it. All the best. Stay safe. Well, that was Sandra Dixon, and again, Sandra Dixon at Sandra Dixon 67 at gmail.com if you'd like to get hold of her. She's a BSc in mathematics, grade 8 to grade 12, and today we'll be looking at trigonometry once again. If you'd like to go back to these lessons, so you're welcome to do so. They're available for you. They remain up on YouTube and Facebook. If you've come in maybe through the middle and you would like to know what's happening at the beginning of the live stream, or if you know of someone who might benefit, who's doing maths and might benefit from these sessions, please do share, like, and subscribe to the YouTube and Facebook channels, and share those lessons with people who might benefit from them. And as we've mentioned, these are provided on the YouTube and Facebook platforms, so they're there all the time. People have asked, why are we hosting it in the morning? Our kids are maybe not at school at the time. Well, that's the thing. They are available there throughout. So all you've got to do is just go back, and if you know of someone who can benefit, share that information with them. Well, that's it from myself, Mohammed Fasik Peterson. I hope you have a splendid day. I bid you assalamu alaikum wa rahmatullahi wa barakatuh. And of course, the next time we chat on this platform, inshallah, we'll be looking at another subject in the Matric revision program.